Dear students, in this series of presentation, I would like to give a little bit idea on C programming. This is useful for the beginners. In this presentation, we will see the first C program, different keywords that we usually use in programs, the meaning of variables, what is data type, what are different data types supported in C, what is the purpose of format specifiers. To start this presentation, I would like to take a small program that we usually use when we introduce any programming language, that is Hello World program. As you can see, this program has got three different parts. You can see the first part is comment part. This is very much important to give the extra things, details about your program, the creator of the program, the version of your program, and the purpose. We can say this part as documentation part. To give that kind of documentation, we have to use a symbol called slashes or slash star, ends with star slash. Any number of lines can be given, but must begin with slash star, must end with star slash. The second line that is required, which is a header file inclusion, which starts with hash include. As you can see, I need to display some message in my computer screen as an output. So I must call a required function, that is output function. These functions are called library functions. These library functions are defined in the header file. Before its use, that header file must be included. If that is not included, if this header file is not included, compiler searches for the header file. If not found, gives error message. I will show that in the demonstration part. Then the entry point. That entry point function name is int main. It can be void main also. Preferable to use int main. The meaning is that after the execution, it should return successfully. It should terminate successfully. Any number of statements can be given. Any number of functions can be called. All those must be within open curly bracket and closing curly bracket. These are executable statements. In C, any executable statement must end with semicolon. Here, the purpose of this program is to display a message, hello world. For that purpose, we used a library function called printf. So the entry is taken through a function called int main. Now, I will demonstrate this, how program can be given. The program development consists, the application development consists three different steps. The first step is called editing, where we create a file in a text editor or in an integrated development environment ID like code block, dev, C++ or any such, where compilation, execution, debugging are all embedded together, integrated together. That is why this is called IDE. This is an example for IDE. Different steps for developing an application consist editing, where I have to create a program. Where I'm creating a program, I should save that in a file with extension .c. Okay, here I'm creating a file, source file, Then save the file with extension .c. This is C source file. My first program f1.c is my program. If file exists shows error message, we'll change that to f1 underscore 1. This is my file name. Then it is the better practice to include any documentation written. Things like date of creation, the author, the purpose, all those can be given here. Must start with slash star and with star slash. Then the second is inclusion of header files. I will come to this point later. Third part of the program is the entry point, that is the main. It can be void main or it can be int main. Whenever you perform the operation, it should terminate successfully. So that can be done with the help of return statement, returning 0. Here I don't have any work to do. Simply I'm going to execute a statement called return 0. 0 indicates that the program is going to terminate successfully. The next phase of program development is compilation. During this phase, any errors, it can be syntax error or wrong usage of instructions or functions. In such cases, compiler produces error messages that I've shown. Purposely, I just missed semicolon there. We'll see what happens at the end of compilation. Compiler produces error message. The error message indicates the line number. There is an error in line number 5. It can be in the 5 or before that also. The mistake is that the whole program is searched, but there is no semicolon for this line. So expected semicolon before closing bracket. Next, user has to update the program. They have to correct that program. They have to save it. Then again you have to compile. Again the program must be compiled. Now the program is error free. Third stage of program development is execution, run. The program is now running and there is no work is there to do, so it is ending at the end. There is no statement, nothing is getting displayed because nothing is given. Okay, now I will modify the program. I want to display hello world program. I want to display some message. My message is hello world. For that I can use any function, but for the time being I'm going to use library function. The creator of C already developed a program, that is a function called printf. This function I'm going to call it, I'm going to invoke it. I can invoke this any number of times. So computer will not think bad, it won't go to the fatigue mode. It can execute that any number of times. I will use one more statement, printf my first C program. Okay, so these two lines are given. I need to display it. When my first work is over, editing is over. Whenever we have to save it. Then the next work that I have to do is compilation. Okay, the compilation. As you can see, there is no incompatible function here because it is expecting something. Either you have to give the code for this or you have to use that header file. For that purpose, you have to include a header file. The header file for this is Standard IO files hash define stdio.h. This is the header file to be included. Hash include stdio.h. Save and compile it. So that error gone. I'm going to run this program. When I start running this program, it produces hello world, my first C program. Both lines got displayed, but not in a proper format. For that, I have to use some commands. We'll see that command later. Again, I have to compile it, then I have to execute it. This is how the output appears in the output. This is the first program. Here, in this, we have seen three things: the documentation part, the header file, the main. Any number of statements can be there. All those statements must end with a semicolon. All these statements must be embedded within curly bracket. This is about the first C program. Now we'll see other parts, other aspects of C program one by one. To write the program, we have to use some of the keywords, some of the result words that has got its own meaning. The developer, they added so many list of words to perform some operations. We'll see all these things in the programs. For the time being, I will introduce all these keywords lightly. These keywords are used to define variables. For example, I need to declare a variable A which can hold a value, and I must say computer that it should reserve that many number of locations. I should tell properly that what kind of data it is going to hold. I'm going to say this with the help of data type. That is, this A is of type integer which can hold 10. So for that, we have got these 5 different data types: int, float, character, double, long. And sometime I need to execute the code repeatedly. For that, I can use these 3 keywords: while, do, and for. When I'm returning from the function, when I'm returning from the block, I'm not going to take any value. Or when a function is going to end, when a block going to end, it has to go to somewhere else without taking any value. That is the while. Keyword while is used. Some more keywords that are used to define variables are auto, signed, unsigned, register, extern, const. These are again used for declaring a variable. To return something, I have to use the keyword return. So we'll see all these things in the slides in the next presentation. Okay, these words has got predefined meaning. That meaning you cannot alter. That is why they are called reserved words or keywords. So these cannot be used as variable. Keeping the first program in mind, display your name in the first line. In the second line, display branch with a space, call it. These 3 information you try to display using C program. You have to use only printf statement. Now we'll start introducing some small concept in C program. The first is variable. It is a name given to a memory location. Suppose this is my computer memory. This has got huge number of locations. We call these as memory locations. Cells, memory cells. All these locations are indicated with a number called address. This has got address 0, this has got address 1, this has 2, this has 3 like that. I'll be numbering all these locations continuously starting from 0. But your computer memory is not just 16 location. It is having millions of locations. For a normal human being, it is very difficult to reach that particular memory location because it is difficult to remember such a big number. For that, I'm picking some location. I'm going to name those locations. For that, a name is given. That is a variable. So instead of using 0 or 1 like that, I'm using variable a. Here afterwards in this program, a refers memory location whose address is 0, or if I use variable c for this 3, here afterwards in my program, c refers a memory location whose address is 3. That's the meaning. So name given to a memory location. Okay. So that exists its lifetime till the completion of the program, till the completion of that block. We'll see little detail later. A name given to a memory location is called variable. The data can be anything. I can put 14, I can keep 1 here, I can keep 10 or 20 like that. These are all called value. 14, 1, 10, 20 are called value, and this is variable. A name given to a memory location. Also called container, placeholder. Here C and A are the container, 14, 1, 10, 20 are contained. Each variable in C has specific type. So you have to tell it properly. Here I gave specific data type like 14, 1, 10, 20. That means these are of type integer. I can also give 1.3, 1.8, 10.5. That means these are all floating point number. Or else I can give even character C, character 1 like that. So all these are of specific type which determines the size of the layout. How much is required? I will take that example now. Suppose my data is of type integer. I'm going to store that in a memory. So the data type decides how many memory locations required. So the language designer, they created data type called integer which occupies 4 memory location. In that location, data is, that is 10 is put. Okay, just generally I'm writing, it requires 4 location. This group of 4 location is indicated with the name called A. A is a container or A is a variable. 10 is a value or content. This is of type integer. In the same way, they've added one more data type called character, which requires only one memory location. Requires only one memory location. That means the data type determines the size and the layout of the memory, range of value that it can hold. If it is of 1 byte, how much the maximum value can be stored. So all these are defined. All these informations are given to us with the help of data type. That is very much important. Variable has got some data type. The name of the variable can be composed of letters, digits, and underscore. Like I can give for this location as A, or I can give this as A1 or I can give the name as A underscore. Anything is possible. But I cannot give a space like A space B for this location. This is ruled out. See, characters okay, letters okay, letters digits okay, underscore is okay, but I cannot give even a number also. For this I can't give number as a variable name, that is not allowed. Okay, even uppercase lowercase also be given, all these are different. So C has this provision, case sensitive variable name, lowercase a, uppercase a are entirely different. Okay, now just for example, how to declare that? We'll see this in this slide. To declare a variable, the data type must be specified with a name. If more than one variables are of same type, then must be separated with a comma. Now we'll take one example. I'm going to create three variables I, j, k, which can hold integer type of data. For that, variable data type int must be maintained. I can combine all these three in the same line separated by a comma, or in different lines also I can give. Suppose 1000 is allocated for I, that requires 4 locations: 1000, 1001, 1002, 1003. So 4 locations are reserved for I. In the code itself 90 is given, that is the value. So it requires 4 bytes: 1000, 1001, 1002, 1003. The next variable I, whose address is 1004. The next variable is j, whose address is 1004. As for me it is very difficult to remember, I am going to use it with a name called j. As I don't have any initial value, leave as it is. It requires again 4 bytes. 4, 5, 6, 7. 1008 is allocated to k. Again 4 bytes. Variable name is k. Like that it goes. So here you should remember that to define a variable, you have to give data type and list of variables separate by a comma. This is variable. While framing this variable, you have to follow those guidelines. You should start with a letter, can have any number of characters, letters, combination of letters and digits, underscore is also allowed, uppercase and lowercase are different, space is not allowed. You cannot begin with a number, you cannot have space between the characters. These are the rules that you have to remember while creating a variable name. These are the different variable data types allowed by C: a character type data, unsigned character, signed character, int, unsigned integer, short integer, unsigned short, long, unsigned long, float, double, long double. So all these are the number of locations, memory location required for these data. Character requires 1 byte, int can be 2 bytes or 4 bytes, short and unsigned again 2 bytes, long unsigned 8 bytes, float requires 4 bytes, double 8, long double 10 bytes. These are all the things that you should remember when you want to compute the memory locations used by these type of variables. Next, I need to initialize a variable also. Here, you know how to declare a variable. Int a is declaring. 10 assigning that to a is assignment, initialization. As you can see, this has got two parts, a equal to 10. I will differentiate these two parts as write value and left value. Left of equal symbol is left value. Right of equal symbol is right value. Left must be a container. Right can be a container or it can be a constant. So a equal to 10 is okay. It is allowed because a is a container. 10 is a number. It is allowed. Or a equal to b. Suppose b is also a container, b is also a variable. This is also okay because left hand side is a variable, right can be a number or a variable. But this is not allowed. Left cannot be a number. Left cannot be a constant. Or 10 equal to a. This is also not allowed. This is wrong in C. Right side of equal symbol can be a number or can be a variable, but left hand side should be a container, should be a variable. Next, sometimes you need to display that value or you need to store some value that you have got, that you want to process it in the memory. Simply you cannot provide, simply you cannot display. For that purpose, special characters are used, special indications are used. Those indications are format specifier. These are used during IO operations. This tells the compiler what type of data is in variable during the input operation or what type of data that you are going to print using printf statement. Some of the specifiers are percentage %C, percentage %D, percentage %F, percentage %LF, percentage %S. C for character type data, D for integer, float for F for float, LF for double, S for string. Then some special characters, some numbers can also be used with this one. If a minus symbol is used, that tells you are going to align in the left alignment manner. If a number is used before, if a number is used after percentage symbol like this, it specifies minimum field width to be printed. If the characters are less than that, it will be adjusting. The number of characters will be adjusted such a way that it will occupy that many number of fields, minimum field that is required. Okay. If it has got more than that, no truncation. If a dot is used, that means in this way 10.5. This is the total width and this much is the precision value. So these three informations given with the percentage, minus symbol or a number or a dot. We'll see with one program. Here in this program, a variable is declared whose value is 15. Series of characters also declared whose value is hello world. I'm going to display it. Okay. I'm going to use format specifier yes, as I told in the previous slide, percentage yes for the string. My string variable is str. I'm going to print it. So in the output after execution, I will get hello world. This is the output. Now, the second, a number is used after the percentage symbol, number is used. Yes, for printing the string. After percentage, number is used. That means it reserves 20 field. It reserves 20 field. How much is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. From here to here, it reserves 20 fields. Then it starts displaying. Suppose it has got 20 characters, no truncation. Otherwise, it will adjust such a way that all 20 spaces are filled. These many spaces, then hello world. Okay, right alignment. If minus 10 is used, that means total 20 characters only, but start from the left. Total 20, but start from left side. Left aligned. Okay, left aligned. The minimum width is used. Earlier it is 20, now it is 10. So it starts from left. If the number of characters is 12, number of characters are 12 and minus is used, so start from here only. Last two spaces are wasted. 10.5s. It separates width and precision. So total number of spaces, the total number of places 10. Out of that 5 utilized. Out of that 5 utilized. Starting from right side. If minus is used, left aligned. Total 10 spaces from here to here. In that 5 utilized. 5 utilized. Out of 10, 5 utilized. Because there is a minus symbol, left alignment. No symbol, plus on the right alignment. Okay. Now, these are the different format specifier. Just have a look. C for character, D for integer, F for float, then LF for double, L for long, S for string, U for unsigned, X for hexadecimal, O for octal. These you should remember. C character, D number, F float, LF double, L long, O octal, U unsigned, X hexadecimal. When situation comes, I will explain it. As I told, the data type specifies the number of locations required. If you have got a character, how much space is required to store that character value? How much space is required for storing integer value, like that for float and double? To know that, size of function is used. It is a compile time unary operator used to compute and return the size of its operand. Size of it is executed at the time of execution. Operand is character. Now what is the size required for this? Character requires 1 byte. As I told in the previous slide, character requires 1, integer 2 or 4. In this compiler, in this compiler it took 4 byte. Floating 4 and double is 8. The operand that is passed to this one, that amount of memory allocated for that is written. How much is allocated for this double? How much memory cells are allocated for float or int or character? That is displayed because you got print statement. The value is written, that value is printed because of the print. Now I will show how to declare a variable. Here A, C, F, T are declared. A is of type integer, C of type character, F of type float, T of type double. Okay. Next, the default values are displayed. Default values of these are displayed. C is a character whose default value is null. Okay. Then these are floating again. For numerics, all values are 0. For character, it is null character, nothing. Let's try one more program to display any number of your choice in this manner. Okay, just for a hint, this is integer number, this is a floating point number. Some number of spaces used, it uses right alignment. Maybe if it is of 20 spaces, 20 percentage 20D. That means it requires 20, it reserves 20 columns, then starts printing 15 from the right side. Here, if minus is used, minus 20, total 20, but numbers start from the left side, left alignment. This is for the right alignment. Okay. Then here, again for the floating point number, just try this program. With this, I'll be ending this presentation. In the next presentation, we'll take some other topic. Thank you.